today, which is accelerated data-driven development with MCP Toolbox for AlloyDB, using Gemini CLI and deploying it on Cloud Run. We already discussed the overview. We have built the dynamic hybrid retail experience. If you have not done it, it's okay. This is not a continuation or anything. You'll go ahead and understand. You go ahead and continue with the code lab. They're quite independent in the nature of how we're doing it. But this is the first lab. This is the first part which I implemented. The lab that you did on the session 2 was the second part. But we did the second part first because we wanted to see the end-to-end application working. We wanted to deploy it in Cloud Run. But that's not the focus today. What is the use case? How we got to the use case, and how we use Gemini CLI and how we use MCP Toolbox. That is the main part, and that's what we'll do today in our hands-on. If you want to see the app or see what we did in session 2, there's a hyperlink to a journey where we built that application. It's there in the overview part of the code lab. Right click, open that in a new tab. You don't have to go through that right now, but I'm just saying that code lab is also available for your reference. But don't worry, there is no dependency for you to have implemented beforehand for you to follow today's session. So don't worry about it at all. Okay, so what we are building, like I said before, it's a hybrid search retail experience. Hybrid retail search experience, and the database of choice is AlloyDB. Of course, it's faster analytics, faster writes, and fully managed Postgres compatible database for real-time data, as well as the real-time and fast AI capabilities and high performant AI capabilities that any retail experience or application would need. So this application has combined the power of faceted filtering and vector search, and that's what we saw. You'll still experience that in the backend today. We'll get to that in a bit. But before that, we have already set up the project, activated credit. So the before you begin steps are all complete. What we want to understand right now is what we'll actually build. So in today's session, you'll learn to integrate MCP Toolbox with your application, or rather directly into your IDE for direct interaction with your database. Some examples of how to use Gemini CLI to write and execute SQL queries and also understand your retail data or any data for that matter. And we'll also understand how we used how we leverage these two to expedite or accelerate our application development and database workflow significantly to complete our application development. All right. So this step is complete. Come next to step 2 of the code lab, which is before you begin. So we've already completed the first 3 steps of before you begin, or rather 2 steps of before you begin. We'll go to step 3 now. But before that, show of hands, can we continue? Thank you. So let's get started. Now that you have your Google Cloud Console open, great. Let me just quickly save everything. Okay, so everything is right. This is the project I want to work on, and you also have everything that you need here. So step 3, activate Cloud Shell. So you see right next to the search bar, there is a Gemini Cloud Assistant chat icon. Right next to that is your Activate Cloud Shell button. Click that. It should open your Cloud Shell terminal. Authorize. We probably don't need it now, but we'll need it at Gemini CLI times. It's already out there, but for now, just make sure your Cloud Shell terminal is open. So this is your Cloud Shell terminal. This is helpful for you to interact with Google Cloud Services and your projects that you write in the Cloud Shell editor. All right. So make sure your project is visible here. When I say project, this is the Google Cloud project that you just created and associated with your billing account. Cool. Now you can just compress that thing. You can slide it down, and you can talk to the search bar directly. So what do we want to talk about? First things first, before we talk to anything, we have to first enable the required APIs. So if you go to point number 7 of the step 2 of the code lab, enable the required APIs, which I'm highlighting right now. Follow the link and enable the APIs. If you see the link, the word link is hyperlinked. It's blue in color. So right click and copy link address. Once again, I'm just trying to, from this point, if you have questions related to the lab, you can send them in the chat messages. Please don't send questions about previous sessions or questions about result submission. We'll take all of that at the end of the session. Anything related to the session, the lab that's going on right now, please use the chat to ask your questions. The reason why it was disabled was because of the questions that were unrelated previously in the past sessions. But I've enabled it now so that uh, we are not going fast, or we don't have blockers for you. That's why. Yeah, our leads are there, and they'll be able to answer your questions. Okay, so now we have copied the hyperlink from the code lab, which is used for enabling APIs. So why do we do this? Enabling the APIs. So this is to tell Google Cloud that you're going to use this particular service for this particular project that you're working on, and you need this because you want to use that service in your application. That's why. So we have copied that hyperlink. Now go head to the window where you have the Google Cloud project open. So paste it there and remove all the UTM links. It doesn't matter even if it's there, but it's not necessary. Hit enter. You will be able to see the APIs that you need to enable in this list here. First, confirm project, click next, and then look at the APIs that you're enabling. First thing is AlloyDB API. The other things are related to Vertex AI and some related to Cloud Run and all. But first things first, AlloyDB, that's what we're going to set up. Click the enable button in the bottom. It'll take about a few seconds here, and you should be able to enable the APIs that we need for this project. Okay, great. My enable API step is complete. As you can see, it's all completed. The check mark is here, and also the enable button is disabled. Cool. So now I'll go ahead and close this, or rather leave it as it is, because we'll come back and use AlloyDB from here. But before moving on to the next step, show of hands, how many of you got through this step? Okay, thank you. Once you confirm, please lower so that each time we know that we are taking fresh poll. Okay. So now going to step 3. Great, we're already at step 3, which is database setup. So what we're going to do here, go to your search bar in the same place where you have enabled the API and search for AlloyDB. Like I said, AlloyDB is a fully managed Postgres compatible database that has super fast transactions and analytical, it's suitable for your super fast analytical requirements and transactions. Here we are. What's the next step? Create cluster. So let's go ahead and click create cluster. Your cluster ID. Please follow the instructions in the lab so that sometimes you don't need to change a lot of things. So cluster ID in point number 3 of step 3 of the code lab, the cluster ID is mentioned as vector-cluster. Go ahead and paste that. Password, just copy the password that's there in the code lab. This is okay. If you want to keep it checked, that's fine too. It's another way to log into the database, but you anyway have your cluster, the password and SQL user, so it's okay. You can take 15 or 16, whichever you want to choose. The database version, latest is good too, or something that was chosen by default is okay too. Region, choose US Central 1 and show advanced options. Scroll down. If you see the instance ID field is pre-populated for you, don't let it be pre-populated. Change it to vector hyphen instance. It says vector cluster primary. Remove the cluster and primary. Instead, change it to vector hyphen instance. It is mentioned as an important note in the last section of the step 3, but I'm just telling you already right now, so that's okay. Yeah. And you can choose zonal availability. Single zone is fine. Choose single zone because it's okay. We can do US Central 1. All right. Scroll up a little bit and check if we have missed anything here. No, everything is good. Machine type is all fine. Enable private IP. That's also okay. Private services access. Is the networking step done already? Show advanced options in the bottom as well. Did we skip past a networking step? No.
That is in the instance.
Ah, yeah, right here. Say connectivity. So your network, choose default. Private services access, choose default and set up connection. We shouldn't have to do private services connectivity. Just a second. Where is my instance? Okay, here we go. Single user, sorry, single zone. Mm. It's okay. Let's go ahead and do this. We need to set up connection anyway. Choose network as default. Set up connection. Click set up connection. And scroll down. Use an automatically allocated IP range. That's fine. Click continue and create connection. So this should create your default connection for your instance. In addition to this, I'm also going to ask you to do a public, like enable public IP access. The reason being the tools.yaml, which you'll use eventually in Toolbox at a later step in today's session. We have set up the connection mode as public IP. So that's why. But this is just something that's important too. So let's do both so that you know how to set it up. And then we'll enable the public IP as well. This will take a few minutes to complete. So this will be a good time to wait for the folks who are still, but either way, even if you reach this step, it'll take some time for folks who are behind as well. So let's get this done. Meanwhile, while that is loading, go to data ingestion step and see everything that's there so that we don't have to go through all these concepts in this particular step when we get to building that in the database part. Wait, is it already created? Okay, so it's done for me. You see the green check mark next to the private services access. So it's successfully created. Show of hands, how many of you got this done? Like got this private services access created for you? Okay. How many of you are still in progress with that step? Okay, let's give a minute here. So this is still just the network connection setup. The actual, once you click create cluster, that will also take some time. So yeah. Okay. Meanwhile, for folks who have already completed this step, go ahead and enable your public IP. And for authorized external networks, it should be you can actually get your IP of your Cloud Shell machine, go to Cloud Shell terminal and enter ifconfig. So remember the Cloud Shell terminal that we activated and is open in the other tab, if which we just pushed down. So expand that, come back here and just do ifconfig. You should be able to see the one with the eth0 inet address. Where is that? Okay, this is the one. It looks like this. 108803, something like that for you as well. And then what you have to do is you have to paste that and then replace the last two digits with 0 0.0 and then with a mask size of 16. It should look something like this. Let me show my screen as I paste it here. Instead of 0.3, make it 0.0/16. So that's what you need to do. And that's it. And then go ahead and click create cluster. Now this will take some time. So, why? Cluster per project is exceeded because I already have 3 clusters in this region. So let me, you don't change anything. I have exceeded the limit for my trial account. So I'm going to change the region, but you don't follow what I'm doing. Please go ahead and continue. Okay, where to find the IP? So go to your Cloud Shell editor. That we had opened previously and do ifconfig. Once you do ifconfig, you get something like this. This is an optional step. I mean, in this case, it is mandatory, but then either one, this or that, you can enable. So that's why it's not there in the code lab. But if you do ifconfig here, you can select your IP address from here. You see eth0, and then you have the inet address here. So that is the IP address you need to copy, 108803. And instead of 3, you'll replace that with 0 0.0, and then you have a mask size of 16. This is your IP range that you're allow listing. So what you're doing here is you're allow listing connections from this IP range. That's why you're doing this, and then you're adding this in your enable public IP section. Once you've added that and also added the private services access, go ahead and click create cluster. Let's see what happened with my cluster. Okay. Vector cluster. I think my cluster is created. Oh no, it's still going on. Instance is getting created. If you remember, this is the step which we used the direct endpoint of my instance last time when we did the application development for it. So now you're seeing how we get to the point of setting up the database, ingesting the data, performing vector search and all that in this step. While that's loading, let's go over the data aspects of the lab. So if you notice right here, Once the instance is created, you will be able to see the AlloyDB Studio. And once you go to AlloyDB Studio, you will be able to log in with your username password, which we created before. AlloyDB Postgres is a default user that you get with it. And then create extension. We need to create this extension for ML integration because we are going to integrate it with Vertex AI, and also vector because we are using PG vector extension for embeddings. So we are performing, if you remember, the application is retail search. We are doing hybrid faceted search plus vector search, which is natural language search, which is converting your natural language text or images or whatever it is into embeddings and performing a comparison with your embeddings from the database. Excuse me. And that's why we are using the we are creating the extension for PG vector. And then we have our apparel table with all the necessary details. And then you grant execute on embeddings function to the user Postgres because we want to run embeddings function on the data, on the description. I'm not looking at the data or schema right now because we'll get back to that at a later step. And then at this step, what we are doing here is granting Vertex AI user role to AlloyDB servers account. Why? Because you're accessing the models from AlloyDB. So you want to activate and grant the access the Vertex AI user role for your AlloyDB because your data is in AlloyDB and you're invoking ML integration from AlloyDB data. That's why we are we are running these commands from your Cloud Shell terminal. Next is loading your data to database. So for this, right click and keep this insert SQL data open so that you can copy some selected inserts 25 to 30 rows, which is in the third tab of the lab. Sorry, of the Google Sheets. You can just copy those 25 to 30 and insert because with $5 credits, you can't do much of embeddings update. I mean, of course, you can deal with a lot of data. That's not AI or embeddings model invoking. Anything else you can do. The only thing you will hit a rate limit on is using the embeddings model, but we have to use it. So that's why I've selected some 25 to 30 rows. So copy that. Don't copy now. I'm just saying this is what we'll be doing at this step. And then creating embeddings for that data. While we'll talk about that in a bit, let me just quickly see if my cluster and instance are created. Yes, my cluster and instance both are done. Show of hands, anyone else got your cluster and instance created? We'll give it like 2 more minutes because I know it's a time consuming process. Sorry, my voice is going in and out. I'm under the weather a little bit. So yeah, you can also create, add the public IP after creating cluster. Don't worry about public IP if you don't have to do it as part of the step. You can come back and edit the cluster later and add the public IP. If you're not able to connect to your toolbox server, only then. ifconfig in one word, not space. I think it's an autocorrect, Akshay. I understand. Okay. One more time, I'm going to ask that question. Show of hands, how many of you completed? Those who didn't raise your hand before probably can confirm now. Yeah, if your instance is still in creation, you will not be able to access Studio. Instance ID, Amisha, it will be there in the advanced configuration. It's a collapsed section. You have to expand it and you will find instance ID there. It should be there in the cluster setup page itself. It's okay if you forgot to change it. That's fine. Just remember what your instance ID is. You don't have to remember. You can always come back to the AlloyDB console and you can
boom, Bappa, boom.
and the list of instances you've created. You can always come back to the list of clusters and the list of instances, and then you can find your name, instance name there. So don't worry about if you did not copy if you did not change the instance name, or if by default it gave you a value and you accidentally clicked create cluster, it's fine. Go with it. Okay. In the interest of time, we have to keep moving. But once the instance is created, you will be able to click that instance. And if you slide to the navigation menu on the left, you will see Alloy DB Studio. Click that. Once you click that, in the database dropdown, you see Postgres. Click that. And there are two options. I'm going to just use the built-in database authentication. If you notice, we also checked the IAM database authentication. IAM means identity and access management, but I'm not going to use that. I'll just use the built-in database because it's easy to select from the dropdown. Postgres, password, you all remember what we entered. It's AlloyDB, all small. Go ahead and click authenticate. There we go. So my schema table, you can see that navigation menu, the Explorer menu on the left, and you have the untitled query in the right. Now, going to the code lab, go to step 4, copy the ingestion stage, which is create extension DDL. Copy the DDL, paste it here. So both extensions should be created. You can run one at a time or run both. There we go. So my extensions are created. Next, create a table DDL, copy that, run that. Great, my table is created. Now I'm going to grant permission to run embedding. Grant permission to the user, the Postgres user, to run embedding in this schema. Done. Run this command. Copy this, come back to your studio, and then click the run button. That's what I did. Now, next is for giving it the Vertex AI user role. So how would you do it? There's a Cloud Shell command here, project ID, and then you will do the gcloud projects command here. So copy this. You're not going to run this from Studio. You have to run it from Cloud Shell terminal. Remember the terminal that's open in another tab, paste it here. I'll explain what it does, but hit enter and give it some time. While it is loading, just come here. So in the first command, you're getting the project ID and storing in this variable called project underscore ID. So basically, it is getting the project ID's value and it's storing in the variable called project ID. In the second command, what we're doing is we are binding the IAM policy for Vertex AI user role here to the AlloyDB service account, which is mentioned here. That's it. All right. So we are done with that. Go check Cloud Shell terminal if this is done. You do not currently have an active account selected. So this occurs when you're not authenticated. So what I'm going to do is gcloud gcloud config set account. So this should technically be there right above your screen. You should be able to see that command right here. Config set account, or you can just do gcloud config set project. Let's see first if project is setting. Sorry, that's not my project ID. My project ID is AlloyDB projects, this one. So I'm going to copy that and paste it here. If you notice in the before you begin step, there's this command gcloud config set project. At that time, we didn't have to do it, but now turns out we have to do it because it's it's already logged out or something. Right. So now I'm going to run this command, which I tried to run before. The project ID and the authentication command, which is gcloud projects add IAM policy. Just go back to the code lab, go to step 4, scroll down towards the end of that particular step. You see that Cloud Shell terminal command here. Cloud Shell command. Just copy that and come back here and paste it. Okay, so it's not authenticated for me. So what I'm going to do is I'm going to run a gcloud auth login. So if it errors out like this for you as well, just run this command gcloud auth login. So once you do that, it'll ask you a question. Do you want to continue? Say yes, capital Y. And then it'll give you a link to sign in. Click that link. Choose the right email account. Say continue, allow, and copy the login code. This is not going to happen for all of you, but if it does error out, then run this command gcloud auth login. And once you pasted the verification code, click enter. So now I've successfully authenticated. So the command is here. I'll paste the command here for your benefit. Oh, why can't I see? Okay, here I am. Okay, Leeds, one of you, can you just type that in the chat? I'm not able to get to the meeting window because. Okay, here I am. gcloud auth login. No, not that command. gcloud auth login. In case the above command that Jaira just sent is erroring out for you, then use gcloud auth login to log in and authenticate yourself, and then try the command. Now go to the code lab, copy the Cloud Shell terminal commands that you need to run from here, paste it, and then hit enter. So now it should authenticate. Okay, you should see these bunch of roles getting assigned to your service account, AlloyDB service account. That's it. So mine is done. Show of hands, how many of you got through the step as well? Okay, thanks for confirming. Now, data ingestion is done. Sorry, data ingestion is not done. Setup is done. Now we are going to do the data ingestion. So remember the sheets link that's there in the code lab where it says selected inserts 25 to 30 rows tab. Right click, open that in a new tab. You should be able to see the apparel data Google Sheets, the third sheet. Just copy, probably just copy all of them. Copy the 25 rows that's there and come back to your Cloud Shell, sorry, not Cloud Shell, your Google Cloud console where you have AlloyDB Studio open. Paste it. You should be all set to run this. So we are just inserting 30 records. If you see in just a second, it's all inserted. So now write a select command to make sure you're able to see the data that the 27 records that we just inserted. Okay, I'm able to see all the 27 records I have inserted. But if you notice, my embedding and image embeddings columns are null. That's okay because we have to run embeddings still. Perfect. So our data is all set up. So this step is done in your code lab. Now we have to move to create embeddings. But before that, show of hands. How many of you completed inserting? Machine series, leave it as it is. Don't have to change anything, Chayan. Okay, creating embeddings. So we have discussed this in so much of a detail in the last session about what are embeddings. So I'm just going to give you a one-liner. Embeddings are numerical representations of the data, any format of data, text or whatever, multi-model, depending on the model you're using. So in this case, we are going to use text embedding 005, which is a text embedding model, which converts text to embeddings. Embeddings are numerical representations or vectors. So if you want to see what an embedding looks like, just copy the sample select SQL, come back to your cloud editor, AlloyDB Studio, and paste it here and run. You should be able to see the embedding for the text. AlloyDB is a managed cloud-hosted SQL database service. That's all. That's the one-line text. And this is the numerical or the array of floats representation of this particular text. Why is this needed? So that you can search for a text in a bunch of or in a larger portion of text that you already have in your context or in your database, so that you're not just matching by keywords, but you're matching by context, by relevance, by natural language, and by precision, and not just going by keywords. Okay, so that's why we need this kind of data. And also, not just the relevance and precision, it's also the speed. How long will it take for you to compare text to text, or image to image, or text to image, and all this? It's a lengthy process and a time consuming application development in itself. So this expedites not just the development experience, but also the search process itself. So that's in short what embeddings are. So now what we are going to do is, we know how to create embeddings. So we are using this method called embedding, and we are using this model text embedding 005. By looking at it, AlloyDB knows it has to use a text embedding model of Vertex AI. We have already given permission for AlloyDB service account to use your Vertex AI models. That's why it's able to run this. And here, this is the user search text that is being converted to embeddings. Now, what I'm going to do, I'm going to update all of my records description, that is product description field. I'm going to take that field and I'm going to convert it into embeddings and update it into the corresponding rows embeddings field. Yeah, so copy this update statement, come back here, paste it in the AlloyDB Studio, and run it. Since we have only 27 records, this should go through. If it doesn't, if it fails with 5 record or 6 records, it is possible because it's a trial billing account. You will have to change the where clause, but now let's see if it is running and it updates. Okay, so my embeddings update is done. As you can see, statement executed successfully, and I'm able to see the records with embedding generated for all the rows. Show of hands, how many of you completed this step? Yeah, Shashir, that's cool. If you're getting permission denied on the resource, you're probably not run the enable API, or you missed the access command, Madhu. Go through the code lab. It's still running. Okay, we'll give it a minute here. We'll skip the next embedding update. Don't run that. We don't need it. This is if you want to use these image embeddings and make some advanced functionalities or features in your application, or you want to try it out, you can try it out. The reason I've kept it here is for you to understand that AlloyDB supports multimodal embeddings, not just image to image, but also you can search by text and get images in response. You can search by image and get images in response, so on and so forth. It's like end to end. So that's the reason I've kept this here. But just know that we don't need this last update here in this particular hands-on. It's not mandate. So we'll skip that. Okay, Madhu, you ran grant execute on function embedding to Postgres and you're getting permission denied. There is another way to activate this, but I'm thinking you're using this from you accidentally switched to another account or something, Google account, your mail account or something, or you opened it in another tab, which probably opened in another login account or something like that. Because if you're able to, if you created your project and this project belongs to you, you should be able to grant execute. For this step, you would not see permission denied. There's another way. You can go to AlloyDB Studio here. AlloyDB here. And you can right click on the primary cluster, open link in new tab. Sorry, not here, but yeah, this page, the cluster edit page is there. No, scroll down. Um, Where's the edit option? Here you can do edit primary and scroll down, add database flag, enable faster. No, this is only for faster embedding. Um, what else was that? Vector. Oh, one more thing. Did you enable vector extension? This is not for everybody. This is just for Madhu. So please don't get confused. She's getting permission denied on the embedding. So that's why. You have to make sure you have your vector enabled and you have to make sure you're in the same account. So please check that as well. If those two are aligned, then you should be able to grant that permission to this user. We'll get back to that. You'll probably have to debug why you're not to, but that's not your, if you're the owner of this project, you should be able to change the access permission, access rights and other things. Okay, so we have completed the embeddings generation. We have updated the apparels table with the embedding for text. We are not updating the embedding for images. So moving on to next step, MCP Toolbox for databases. At this point, I want to invite our speakers for the day from the MCP Toolbox Toolbox for databases Eng team, Anubhav and Disha. Do you want to
Yeah.
take it up for? Yeah.
Thanks, Abhirami. Thanks for the great setup. Hi, everyone. I'm Anubhav, and I've been working with Google for around 3.5 years or more. And joining me is Disha, uh, who is also joined as a lead in this call. We both will be presenting Toolbox. Uh, Meanwhile, Abhirami, could you grant me co-host access? I think it got reverted because of the call drop, so that I can present my
Yes,
screen.
we do.
So I and Disha work in the databases organization, creating toolings around databases that can work with your GenAI applications. And we are actively working on MCP Toolbox. Disha will be responding to your chat queries around MCP Toolbox, and I will be presenting uh, Code Lab, part of the Code Lab, where Abhirami has paused. So I have a, um Cloud Shell terminal. I'll just quickly go through the steps in the interest of time. Uh, so what we'll do is we'll set up a MCP Toolbox server. So I'll just quickly introduce what Toolbox is. It's an open source server that helps your GenAI applications, particularly your MCP agents, to connect with any database easily. And the way it makes the database accessible to your agents is through tools, and we'll see what those are. And uh, it basically simplifies the development uh, so that you just focus on your application logic and the code, and not get into how connection pooling has to be handled with the database, or how authentication has to be handled with the database. All of that should be handled behind the scenes by MCP Toolbox, and we'll see how that happens. So here I just created an empty folder, just getting
You'll have to zoom in your screen a little bit. Yeah, thanks.
tool. So what I'll do is Toolbox is offered as a simple binary along with other options like Docker containers or things like that. So we'll just go with a simple way of downloading the binary. You can just download a particular version of Toolbox. This is the storage link from where you can download. Just make a quick curl call and make sure to set the OS and the platform that you're using. The Cloud
One,
Shell should.
yeah, so sorry to interrupt, Anubhav. Just show them the code lab steps so they can copy
Okay,
from there.
Sure.
from the mkdir step.
Yeah. So I'm just copying the command from the code lab. That's it. So this is the mkdir command, and this is the curl command that I copied from the code lab. So what this command does is you can change the version to the latest 0.15, and the curl command should remain as is. This platform and this OS should work fine with your Cloud Shell. If you're using Mac, you could change it to something else. You can check out about this on the GitHub repo link, which I would ask Disha to paste on the chat group if we haven't already. And this third command is just to make the toolbox binary executable. So this is what I did. And just a quick tip for this code lab, we are going to require the full path of toolbox. So I'll just paste the full path of toolbox binary, which we now have made executable. Okay, so at this point, so let's now configure this binary that we have downloaded to actually work with the database, AlloyDB database that we have already created. So the way we do this is by just creating a simple config, oops, which we'll call tools.yaml. And I'm just going to paste a simple uh, tools.yaml config from the code lab, this one. And that's it. So what we have here is a couple of things. Let's go over this one by one. So toolbox configurations have two things typically. One is the source and other is the tools. Sources are the database sources from where the agents would fetch the data. And tools are the way the data would be fetched from your tables in your database. So typically it would look like one or more sources and one or more tools in the tools config. You can have one source catering to multiple tools as well. So let's go over the sources. I just named my one source as AlloyDB. You can name it anything. It's a kind of AlloyDB on the Postgres flavor, SQL flavor, and you can just change the project ID. I'm going to name it my project ID. And other stuff should be similar to what we have said before so far in the code lab. And now comes the interesting part. So tools, we can configure multiple tools to be provided by Toolbox to our GenAI applications agents. And one of such tool is Get Apparels that we'll be providing to our agent. And that agent is going to use a Postgres flavor SQL in the statement, which we'll come to later. The source would be one of the sources that we have defined above. It's going to be AlloyDB. And description. So this is really interesting one. So this description is what defines your tool. So you're going to explain in natural language, however complicated you want it to be. You can define in natural language where and when your tool needs to be used and what it's going to return in natural language. And the statement is the exact SQL statement that your tool will call under the hood to fetch the data. So in this case, it's a very simple SQL call, which will just fetch all the 27 rows from the toy data set that we have created in the previous steps, but you can make it as complicated as you want. That's it. So I'm just going to save this tools file, and we have a toolbox binary and a tools YAML. That's it. Uh, So now I'll go to the next step where we'll actually run the toolbox binary that we've downloaded and feed it with this tools config. But the way we would do it is toolbox through Gemini CLI as an MCP server. Yeah, at this point, I'll give it back to Abhirami. Abhirami, would you like to continue from here?
Yeah, sure. Thank you so much, Anubhav. So we'll get to the operations that we have performed in the tools in our tools.yaml. But before that, just a show of hands, how many of you did that step, MKDIR, Gemini CLI project, and CDs, Gemini CLI project? Basically, what we did is going to that Cloud Shell terminal, create a brand new folder for this session that Anubhav walked you through. It's the same project, but then just another folder. And then you navigated into the directory. I'm going to share my screen now. Can I take over the presentation, Anubhav?
Sure. Yeah.
Yeah. So let me show you. Yeah, you're in the Cloud Shell terminal. So you probably did this MKDIR and then Gemini CLI project. And then I have navigated into Gemini-CLI-project. And then what I did, I went into editor, which is open editor, and then search for the project that you just created. Click new file icon, do tools.yaml, which Anubhav already showed to you. You probably already covered it. Go to tools.yaml and paste the code and replace the values. I'm just going through the steps again because at that point I was deleting some files from here because I didn't have enough space in this sample, my personal Gmail account. So I'm going to delete some of the projects to make some space here. So please bear with me for a bit. I need to delete something. It's not saving. Okay. Yeah. So what I'm going to do is I'm going to give my project name here, which is the project ID, AlloyDB projects, not the name, but the ID. You have to click the project picker and get your ID, paste it here. And that's pretty much it. So Anubhav already explained what it does. This is the part where you connect to AlloyDB, all the credentials. Here, there is a small catch for folks who accidentally let the name be whatever the default name was. You probably didn't have it as vector-instance. So go back to your AlloyDB tab and see what your cluster ID is. In my case, it's vector cluster. My instance name is vector instance. In that console page itself of AlloyDB itself, you should be able to see what your instance ID is. So copy that and come back and paste here. Don't leave with the default value. It might not work, right? So get apparels. So what this tool does basically is just a simple select statement. It gathers all the data from apparels table into this tool called get apparels. But in the what do you call the application that you deployed in session 2, we had a lot more tools in there. If you're curious about what all tools we used in that particular session, it's linked here in the repository that you went to, right? Remember the GitHub repo that you cloned in that session, or probably took the apparel data from? It's there in step 4. Right click the insert script SQL, open link in new tab. It's opening only the thing. Let me see if I have the repo here. I don't have it here, but I'll paste the link to the repo here. 1 second. Repositories. So if you go to Precedent Searching Retail, I'll give you the link on GitHub repo link. So if you go here, there is a tools.yaml. It's not needed for today's session. This is just for you to see the sophisticated queries and the tools we used, which Anubhav was just mentioning. No, you can write whatever you want to communicate with your database here. So we used all these sophisticated re-ranking and faceted filters in our app. But that's not the point today. Today's point is all about understanding how we leverage Gemini CLI and MCP Toolbox to talk to your database. So we are going to keep it simple as possible. So that's why we are just taking a select star from query. While we go to that, if you're interested in looking at this GitHub repo for your the rest of the tools.yaml, the entire file, you probably can go reference this. This is there in the session 2's code lab as well. So you've probably already seen it. All right. So now I'm going to go back to my tools.yaml. This is fine. So what I have here is select ID, content, URI, category, subcategory, color, gender from apparels. That's all I have. Now, going back to your code lab, let's see what else we have left there. 1 second. I'm just losing track of my windows and tabs. Okay, here we are. So we are in step number 6. Anubhav completed step number 6. So we have to go to step number 7. Set up Gemini CLI. Did we already? Yeah, we completed all of this. So set up Gemini CLI. So what we're going to do, we already all know what Gemini CLI is. It's just the last and second last step for today's session. Gemini CLI again is an open source command line AI agent that allows you to learn, allows you to understand, but allows you to also execute the things that you want to do. So what we're going to do from Cloud Shell Editor, from within the Gemini CLI project folder, which you just created, create another folder. Go to Open Terminal. If you see the code lab, it says create another folder called .gemini. So I'm going to do that. Sorry, it's not yeah, .gemini. So either you can create it from here or you can create it from editor itself. Just make sure you're within the Gemini CLI project. Right click, new folder, .gemini, enter. Does it say .gemini? Yeah, it does. And expand that and right click, new file, settings.json, all small. Now copy what you have there in the step 7 of the code lab. I'll explain what it does. So what we're doing here, this is the part where we are configuring all our MCP servers. In this case, there's only one MCP server we are using, which is AlloyDB server, which is the path which Anubhav asked you to copy. Remember the real path. He asked you to get the real path. So basically, it's pretty much the same for you, unless you renamed and you created multiple nested folders, in which case you know your folder, the path to your folder, the path through your toolbox. This is important because toolbox is the binary. That is the part where we have a server running right now. That's where, and also Gemini CLI is a folder within which we have our tools.yaml, which is there in the args command. So make sure this is configured. So this is simply how you configure all of your MCP servers. Here we have only one. Now let's say you're talking to a Spanner DB server, or no, not Spanner DB server. Probably you can do all that within MCP Toolbox itself. So why MCP Toolbox for databases? The power of that, we'll address that towards the end of in the last step of the session today. But just remember, let's say you have a GitHub MCP server that you want to talk to. You can include that right here. You can just say GitHub server, and then you can configure whatever you want right here. Not whatever you want. It has its own URL. It has its own arguments and all. You have to pass it here with the commas separated between them. But today we are not going to look at that. We are just going to deal with one server, which is AlloyDB server, which is already configured there for you. Unless you change the path to the binary, or there is the toolbox binary, don't change anything here. Everything else is fine. Now, going back to the code lab, installing Gemini CLI. Now, copy the sudo npm install command from here. Go to your Cloud Shell terminal. You can toggle between your terminal and editor within the same Cloud Shell terminal window. Make sure you're within the Gemini CLI project folder itself. And then paste this command that you just copied. Why? Command not found. Okay. npm install, so it is installing Gemini CLI for me. The reason I'm taking this route is I just want to access my folder. You can also access, sorry, my folder, because I have MCP server configured there. You can also use Gemini CLI that's pre-configured to access your file. It's just that it kicked me out from the other, it didn't log me in because that was a trial billing account and I didn't have enough space. So it didn't actually allow me to install or do anything with that. And I don't know why it didn't let me log in as well. So I switched users now and I'm using it in a different account and I'm able to install. So I'm inside the folder which has my Gemini folder, which has the settings.json. So now from here, I can access Gemini. As you can see, it's authenticating me and it's confirmed authentication. So now we have what we need. Um, Here you can see the project from where it is invoked. This is what I wanted. Show of hands, only if you, probably you already completed all the steps. Show of hands. Okay. So some of you completed. Is anyone still facing issue like the npm install step or something like that? Those who completed the step, please lower your hand so I can see if there's people with issues. I don't know if that's a specific issue or you are just raising your hand for completion. In any case, you should be able to access Gemini and you should be able to authenticate and continue to the next step. So if you're able to access and not able to install, do the npm install, you can always click this Gemini CLI tab from here and you can start interacting. In my case, I had trouble doing that in the other login. So I logged in here and I was anyway able to install. So I'm proceeding this way. Okay, now go to the code lab, go to the step number 8, start interacting with Gemini CLI. So now we want to use the MCP server that we just installed, right? So go back to your terminal where you have Gemini open. So do /MCP. This is how we configure, we talk to it. So AlloyDB disconnected, no tools or prompts available. All right. Let's go back and check what is the issue here. Yeah. So I'm going to go to editor, go to your tools.yaml. Make sure your details are all correct. Gin, vector cluster. Okay. Get apparels. This looks okay to me. Let me just check with AlloyDB if this is all accurate. Okay, so vector cluster, vector instance, this is where I am. Wait, do I have the public? Okay, enable public IP, that is also done. Everything is done, so I'm not going to update anything. Should be good. What else is there? Now let me go to AlloyDB Studio and see Express user authenticate. Okay, I have the apparels table. Let me copy the query from here, from your editor. Just see if that works. We need to make sure it's all up and running. So I'm just testing it. Okay, now then, where is it? It's right here. Okay, run. Okay, so it works. So we have the connectivity and everything accurate. We have the details correct. For apparel data, tools.yaml. So this is perfect. Now let's go to settings.json. Let's check if this path is correct. AlloyDB server. Okay. Home user. You can also check the path from here. Copy relative path. Toolbox. Oh, okay. I think I know what's going on. Oops. Yeah, so that's what it is. My path was wrong. So if this is the your case as well, just replace the path here. So it was not users, it's my user ID. So now I'm going to go to Gemini, open terminal. It was transferred somewhere else. Yeah, it's right here. So I'll do MCP again. There we go. Where? So let's disconnect, Control C, exit, and restart Gemini one more time. Yeah. MCP. AlloyDB server is ready. Do you see that? So now it's connected. So my problem was that the path was wrong, which I just overlooked. So that's probably your case as well for folks who had that error. Were you able to fix that as well? Were there other errors? Okay, if you have a specific error, fail to get instance IP address or something like that, your error is right there in the error message itself. But for folks who got disconnected, it's probably the path error, all right? So I'm going to check with you now. So show of hands, how many of you completed? I see 2 hands up, but is that all? Path error, okay, please go ahead, fix it. Disconnected, it means your go to settings.json. If you go to settings.json, you can see that your path to the file that we were just talking about, settings.json, the path to toolbox binary was incorrect in my case. So that's the issue. So you just copy the path and paste it there. So now I'm able to connect. Now let's go ahead and complete the lab. You'll get the recording so you can do it at your time as well. So we are already 8 minutes over. So let's just go ahead and finish it, and then you'll get the recording for fixing errors or other things. So as you can see, you have 10 tools in the screenshot. Don't worry about it because I showed you the whole tools.yaml that I had in the GitHub repo, which had a lot more tools. But in this case, I have only one tool, which is the select all from that particular table, apparel table. Yeah. So now you want to ask questions. You want to talk about what it has. My data set again is not entirely accurate. So I would take the responses and take the data with a grain of salt because it's not so the data is not thorough. Like there are duplicate records, there are probably invalid records, so there's a lot of redundancy and other things in the data. But because this is test data created for the sake of building this application, I wanted to so the original application that we built in session 2 has about 2000 or plus records just for the sake of testing multiple scenarios, so I had to insert duplicates. But yeah, since you copied only 27 records, we'll see what kind of responses we are getting here. How many types of gender this apparel dataset has? So it's asking if you want to allow execution of the MCP tool, get apparels. So you notice that it already identified the tool that you want to run from AlloyDB server, which is the tool that the MCP server that we are connecting to. So yes, you want to allow it, right? So in my case, I want to allow it always. So I'll say allow always. It's processing the output. There we go. So this is my data set that has those so many records that I told you about. But the ultimate response here is the apparel dataset has 4 types of genders: kids male, kids female, adult male, and adult female. This is just at a high level. I had set this dataset, like something random and something really quick. That's why you see these 4 types of genders here. So ultimately, this is the response I was looking for. This is great. Now I don't have to go somewhere and query, do a distinct and see what is there and other things. This is a simple query, so it might seem easy to you, but you can also explore complicated scenarios. Let's see the next one. I'm not saying it's complicated, but just another variety. Give me the SQL that I can use to find the number of apparels that are footwear. So I'm going to paste that. So we are asking in this step, we are asking Gemini to give us this Gemini CLI to give us the SQL that you can use to find number of apparels that are footwear. And then you can probably talk to it and identify what are the unique subcategories of apparels that are there, and so on and so forth. See, it has given you the query that you can use to identify or count number of apparels that are footwear. If you want, you can just go ahead, copy this and run it. Yeah. Oh, sorry. And then I pasted the line numbers, but it'll also ask you to 10 categories. Now I can't validate that because this 10 is from my other email account. So I only have 27 records here. So probably that's how many are footwear in that. We can check it out here. How many are footwear here? Yeah. So now moving on to the code lab, what else do we have? There are other questions. You can understand what unique subcategories are there that I can use to find the number of apparels. No, not the second line, just the first line. What are the unique subcategories that are there? So there are 2 categories, apparel and footwear. Under each category, there are some subcategories. So it has identified both. There's a copy paste error. So just copy the first line and go to CLI. You can ask questions like that. So basically the point is, this is just small, simple questions, but at the same time, more intuitive in terms of understanding the schema, understanding your data. But let's say you have more complicated functionality like we did in session 2, for which the tools.yaml file is mentioned here, if you notice. So how did we arrive at such a complicated query? How did we gather this data? So the way we expedited building this application itself is by using MCP server for AlloyDB, by asking questions that are specific to the use case that you have, and getting the, not just to generate queries. You can just generate queries from Gemini. You can just generate queries directly from Vertex AI or any a large language model. But that's not what you want. You want to be able to interact with your schema, interact with the data in your schema, which today you had access to because you set up the data. But ideally, in a production scenario, you won't be setting up the data. You will not even have access to look at all the data. As a developer or as a user of a certain specific portion or scope of data, you'll only have access to selected maybe tables, selected columns, selected fields. And with that, if you have to build this application or build out a feature, it's not always possible. So this will help you come in handy when you want the application or the large language CLI assistant to be able to interact directly with your data, interact directly with your schema, and respond to your queries, not just by generating SQL statements, but also analyzing it and generating the data that help you understand whether your query will work for a certain, like let's say a DML or a selected analytics query or something, slice and dice that you're doing on the data that you have. So that's where it comes in really handy. Again, I promised to tell you why we're using MCP Toolbox for databases. We already, I mean, Anubhav already touched that. He already gave a high level overview of what is MCP server for MCP toolbox for databases. Um, but just to add on to that, imagine a scenario where you're building a full stack application with multiple databases, some for transactional and real time, some for just streaming, and one database just for analytics purposes. And there are like cloud storage types, storage where you have files and other things. Now you want to have a unified data layer that brings together all these endpoints and gives you an overall vision of what your data looks like. Let's say here I'm just querying one table from one database, so it looks simple to you. Imagine I have a table in MongoDB, not table per se, but it's a document DB, so you have documents there. Let's say I have a set of documents in there. Now I want to join these two, but I want to analyze it in such a way that I know how to use it in a feature. So that's where MCP Toolbox for databases comes in really handy, and it's really powerful because you can configure MongoDB also in MCP Toolbox for databases. And you can also configure AlloyDB, Cloud SQL, BigQuery, and all that. And when you're looking at it from a YAML perspective, ultimately to your application's front, this looks similar. There is no modality difference. There is no document database, relational database. Ultimately, it's looking at data the same way. So that's why it's super powerful. That's why you're going to be using this in your production grade applications, particularly when you have a lot of dependencies, not just one table and one query, right? There are so many data, I mean, so many layers of data and databases that you will probably end up using. And that's where this comes in really handy. But even for small applications, if you see my tools.yaml, if you go to that repository, the GitHub repo, and see that thing, I have multiple tables and multiple applications for which I maintain a single tools.yaml. So anything that I need to do in database, I'll just keep updating my existing tools.yaml so I don't lose anything. I'll always come back to it. That's not a good practice, of course, because maybe one day I'm building a retail search, another day I'm building a patent search algorithm. They're probably not similar applications, but I like to maintain in the same way. It won't be the same case for you, but in your case, your organization might be maintaining its entire or at least one application per se for that matter can be maintaining all its data dependencies in one YAML file. It's not like you're storing the data in the YAML file. It's just that your interactions with the database are being stored in a specific format. If it is a relational database, you probably have queries. If it's a document database, there are other ways to interact with it. So that's exactly what we're doing, and that's why it's powerful. Now, there are more queries here. You can try it out. But for result submission, you need to submit this one. If I'm not wrong, this is the screenshot. Let me just quickly confirm. Sorry. Let me just quickly confirm here. Yeah, step 8, under how many types of genders the apparel dataset has. So this one. This is the screenshot that you see in my screen right now. I'll zoom it. Just this black screenshot over here. This is what you need to submit for result. I'll just quickly paste that link of the app as well as the step. Okay, there you go. So that's pretty much it. This is what we wanted to accomplish. And the next step, which is accelerated app development, is it's a concept of everything that I've been discussing with you today and also in session 2, like rapidly iterating on product filtering logic. If you see, there are so many queries here. You would understand how I iterated over it multiple times to arrive at that complicated faceted search query that we built to dump all that heavy logic in a YAML file and just deal with an agent or a generative AI application at the application level. There is no heavy lifting of data in that aspect at all. And everything that's Gen AI, everything that's agentic AI or embeddings or anything for that matter is all handled at the data layer itself, right where your data resides. So that's what you see, rapidly iterating based on product filtering logic. Like I keep querying, I understand, like let's say based on the brand, size, color, price range, I would want to probably add a new category, or I have to filter out certain elements, or I need to tweak my feature to accommodate a certain aspect of this particular category that we have. so on and so forth. And when I'm building the application, I don't have to switch between my application and the Alloy DB Studio or editor, because some of you may not have access at an enterprise level. So you probably have to use something to understand. You have to build out a whole application to get to the point of validating whether your feature works or not. So those are the scenarios where this comes in really handy, because based on the permissions that your org or your admins can offer for you, you will be able to access that level of, if they have exposed that enough as an MCP server using this toolbox, you'll be able to slice and dice and understand your schema and write your application in an accelerated fashion right from your command line itself. So that's what this part talks about. And this talks about the two elements. One is the iteration of the product filters, and the other one is the vector search filter logic, which is based on embeddings. That's it. This is pretty much the theory part of everything we discussed so far. And because it's Alloy DB, I recommend you to delete the cluster or deactivate it once you submit the result screenshot. Don't forget to do that. But since you can copy the result screenshot from this lab itself, this particular step, you don't need your cluster. Go ahead and delete it. So with that, we complete our session 4 of season 11.